when you're in grade 5 or grade 6, when you're in middle school or when you're going to high school, when you're reading, let's say, science, right? When you're reading about, let's say, photosynthesis, you should not be thinking whether the letter is an H or an I. You should be thinking about photosynthesis. The device got bricked. It stopped responding. It stopped saying anything. It stopped responding to any of the keys. But luckily, they had left the remote access on. Because it had remote access on, we were able to revive that quite easily. It is important because we have users spread across everywhere, and having for every small thing, if we have to get the device back, that's a huge wastage of resources for everybody.
Hello, dear viewers. I'm Grigory from Dataplicity, and today my guest is Dilip from Tinkerbell Labs startup. Dilip is CTO of that startup. Hello, Dilip.
Hi, Grigory. Happy to be here.
So, Dilip, it's end of summer now. How did you spend your vacations?
It's hard to get a lot of vacation time when you're running a startup, isn't it? I'm sure you would know as well. It's been a long summer for us. It's been quite busy, a lot of things
Hmm.
going on. So I work in the field of education, as you might be aware. So we build education devices for the
Yes,
visually
yes.
impaired and the blind children. So we have a Braille teaching device called Annie, and what
Yes,
we
yes,
use
Dilip.
are some
Now,
of.
now I will ask you about all the stuff. It's very interesting, but wait a second.
No, I was just gonna say, summertime is used to prepare for the upcoming school year, so usually that
Uh-huh.
is why we get very busy. So
Okay, okay. So like, yes, it's school year now starting, and you was preparing last time for that
exactly,
start. Okay, okay. That's why you have a busy period.
yeah, yeah.
Understood. Okay. So well, today we will talk about how to make an efficient remote monitoring of IoT devices, and Dilip is a practitioner in that case with huge experience. So well, Dilip, first of all, to our viewers, get the context. Please talk about what about your company, what are you doing? Like you told about that devices, so please
Sure.
extend the topic.
Yeah, so I'm from a company called ThinkerBell Labs. We are based in Bangalore in India. We build education devices for the visually impaired and blind children. So basically, audio and tactile. By tactile, I mean touch and
Hmm.
feel. So audio tactile devices, which enable blind children to learn how to read, write, and type in Braille. Right. So the problem
Hmm.
that we're trying to solve is that of very low Braille literacy rates across the globe. Even in the USA, it's less than 10%. So you have elevators which have which has Braille on lift buttons, but only 1 in 10 people can read the Braille. So that is what we're trying to change. We're trying to improve literacy rates of Braille because
Okay,
there's a
but
very
you mean
strong.
1 of 10 blind people can read Braille? Yes.
Yeah, exactly. So there's a very strong correlation between the ability to read Braille and employment in their future. So that is our aim, to increase Braille literacy rates across the globe and improve learning outcomes for the visually impaired. So we have a hardware device which is roughly about 10 inch by 10 inch, similar to a tablet, but there's no
Hmm.
screen on it because that's not what we're trying to do. So we have a Braille display, which is a digital display which keeps refreshing with moving pins, and we
Hmm.
have a Braille style keyboard and a Braille writing slate, which is very unique to Annie. So basically, if the visually impaired, when they want to write Braille, they use a plastic slate or plastic or a metal slate. They put a
Okay.
piece of paper in the middle, right? So it's like a booklet. So you put a piece of paper in the middle and you
Uh-huh.
poke a hole from this side. So when you poke a hole from this side, the paper rises on the other side, right?
Okay.
So when you flip the paper, you're able to read raised dots.
But
So
wait, like it prints the dots in the paper, yes?
exactly. That is how they write manually. So we have a digital version of that. There's no paper involved in it. But when they poke a hole in our device,
Uh-huh.
it basically it presses a button below it, and then we have a dot that raises on the display. So we have a digital version of that, the digital display. It's a very unique concept. You can learn more about it on our website also. It's a patented device, right? So we've built something, but that basically caters to a very young age group, starting from 4 years and onward. So we have the age group of 4 to 15 years old who use our devices extensively, and it's all catered towards self-learning. So sort of games, gamified learning. You learn by
Okay.
playing different types of games, and you have
But wait a
competition.
second, Dilip. It's like that screen that you have for that visually impaired children people. It's like also
Mhm.
some pods that going up and down, or
Correct.
how does it
Yeah.
look?
So it's made of Braille cells. So the Braille cells have dots that move up and down. So
Okay.
there are 6 dots that form one Braille cell. So depending on which dot is raised and which dot is lowered, it's a different combination. So for example, in English, the letter A is dot one raised. The letter B is dot one and two raised. So when you're reading it, when you put your finger on it, you will know which letter it is. But the problem is it is very small in size. So you need to develop that sensitivity on your fingertips to read quickly. So you need to practice a lot in order to be able to read fast.
Okay.
So see, when you're in grade 5 or grade 6, when you're in middle school or when you're going to high school, when you're reading, let's say, science, right? When you're reading about, let's say, photosynthesis, you should not be thinking whether the letter is an H or an I. You should be thinking about photosynthesis. So that is why early literacy, foundational literacy and numeracy is very important, and that is what Annie tries to strengthen among blind children.
Okay. Okay. It's I must say it's really cool stuff what you're doing. Like it's
Thank you
really
so much.
something noble. You helping people to improve their future with especially with like for people with such big problem. Really amazing that you are helping them.
Thank you so much.
Yeah. So probably like when you come into that people, you giving them that devices and how do they react for that?
Oh, so see, it's very unique, right? So the first few years, we've been doing this for 7 years now, and the first few years, people were very confused. They didn't understand what the device is. They didn't know what it was doing because there's been no such device in the world so far. So it's the first of its kind. So we had to do a lot of explaining, lot of demonstrations to show what Annie can do, how they can use it. Lot of training we had to do, and once they were able to get a hold of it after a little bit of training, then they really liked the device. So what they really like about it is how simple it is for young children, right? So it is not a very complicated device where there are too many buttons or too many options for you to play around with. It is simple, and it is yet easy to use. I mean, simple and easy to use. So we have young kids also picking it up very quickly, and
Hmm.
for teachers, they don't have to be worried about misuse, because the objective of the device is very clear. It only has
Hmm.
learning content, and it will teach you how to learn Braille. There's no
Hmm.
chance of children being naughty and trying to browse the internet or read something they're not allowed to read. So there's no chance of misuse, right? So it's a very well fitting device for schools especially, and for parents to administer Braille education. So even if the teachers and parents are not experts at Braille, they can still teach Braille to a visually impaired child, and that is
Okay.
that is the thing that they really like about it. So these are things that they have told us, that I'm telling you, because we've been doing it for a while now. People understand. I mean, I've heard a lot of great stories about it, and it's really helping people. It's good to see it's impacting a lot of people.
Okay, amazing. So like super. Like you must be feel proud when you do it. It's
Absolutely.
amazing. Well, so let's go now for core of our discussion,
Mm-hmm.
basically remote monitoring.
Mm-hmm.
So as I know, you're using dataplicity for um, basically for what? Like as I understand, for improving some problems, finding some errors if something go wrong. So please tell
Sure.
us how do you use the remote monitoring?
Sure. So our device is built on a Raspberry Pi, right? And basically, in the early stages, so we have Annie speaks to you in different languages. So we have different language options, and all of these languages are human recorded voices. They're not text to
Uh-huh.
speech. So
Okay, so it some has some speaker that like
correct.
explain the letters that children like push in it.
Exactly. Exactly.
Okay,
So the reason we have human recorded voices is because children get bored with text to speech. It is a very robotic voice, right? So we
okay,
have a very soft sounding human voice. So it's as though a teacher is telling them what to do, right? Even though it's a device. So what we used to use it for is two types. One is when we have built something new and we want to test it, we send it to an expert, we send it to a braille expert or a content tester, because we have right now, we have in 12 languages, we're developing 12 languages, we already
oh,
have
that's a
9,
lot.
3 more are being developed, and obviously we don't know all the languages and we need to work with consultants and experts for certain languages. So we send the device to them, and when they're testing it, we use it for things like finding bugs in the device, if any, and if those bugs come up, we use it to sort of fix those bugs remotely, right?
Okay,
And
so you
that is
mean
what,
like they find in that box manually, they report them, like write an email to you or something,
correct,
and after that you like coming into the shell
correct.
remotely and checking and maybe making some improvements in your
That is
I don't
so
know
that is in the
Python
testing
script or
phase.
whatever you have.
Correct. That is in the testing phase. And once it reaches users, we use it for remote diagnostics. So basically, what we have is we have a menu item in Annie. So in menu item, you can go and say enable remote diagnostics. So you
Okay.
select enable remote diagnostics, then data publicity is enabled. So once data publicity is enabled, then the user can let us know saying, hey, I've enabled remote diagnostics, and then we can see if the device is functioning as usual. If there's anything going wrong with the device, we can see, we can access the error logs and find out what is going on with the device, and accordingly we can either fix it right there, or we can figure out whether to have the device come back to our offices, or it needs a replacement of a module, or what is going wrong, so we can do remote diagnostics accordingly. So
Hmm.
that is what we use it for. Even though it's a not so frequent use case, it is important because we have users spread across everywhere, and
Okay.
having for every small thing, if we have to get the device back, that's a huge wastage of resources for everybody, right? So it and also for the kind of audience that we cater to, we want to make it again as simple as possible. So on the device, it is as simple as pressing three buttons and then they enable remote access for us, and
Hmm.
then we're able to diagnose what is going on with their device. So it's very handy that way and easy to use. So these are the two major use cases that we use data publicity for, and that's where it comes in.
Okay, so like that some teacher or tester first of all need to call you and like explain you what exactly gone wrong. After
Yeah,
that, to press some buttons and
correct.
allow you to enter the device. And yes, and as I understand, you can read that logs. You can improve if it's some software case, but if it's some
Correct.
problem with hardware, it needs to return it to you.
Correct. Exactly.
Okay, okay, cool, cool. So, hmm. So and usually, but you said about testing now. But
Mm-hmm.
how about like usual daily use for the teachers? It's also like same. Which kind of problems they usually have?
So again, it's a daily usage. See, there are some things where the device itself can indicate what is going on, right? So we've already built in those mechanisms where uh, if they tell us, hey, if they call us and say, hey, the device is doing X, Y, Z, we'll get to know what the issue is, if at all there is an issue. But
Mhm.
we only use it in cases where it is not something we've previously come across. In
Okay, but
cases
wait, you
like
mean you make some self-diagnostic of device?
correct, yeah, self diagnostics, yes.
Okay, okay. How does it work? How does it look?
So basically, for some of the moving parts of the device, there are some. Okay, there are two aspects of diagnostics, right? So one is auto diagnostics, which the device does by itself, which basically it'll know if a certain actuator is working or not, because these are closed loop actuators. By closed loop, what I mean is the device knows, once the device says, "Hey, go to state A," the device will also know whether it actually went to state A or not. right? So when it says from state A, when it says go to state B, again the device will know if it went to state B or not. So in the
Mhm.
auto diagnostics, it moves things between state A and state B, and it will verify whether it actually moved to state A and state B. So if it did not move, if the device told it to go to state B and it did not go to state B, then the device knows there's something wrong with this hardware, right? That is the auto diagnostics. And we also have a human guided diagnostics where it will say something like, can you please check if the device is doing ABC? And the human will say yes or no. So if it is no, then you know something wrong with it. If it's a human says yes, then it moves on to the next test. So it's a very simple test, runs few lines like that, and then it will get to know, at the end of it, it will get to know what is faulty, what is not working well. So that is a self diagnostics that we have on the device. But beyond this self diagnostics also, since it's a new device and there are, I still say new even though we're doing it for 7 years, because it keeps going through evolutions, new features keep getting added, and as we find out about more ways of doing it, more content we keep building. So if there's anything that goes wrong that we don't have as part of self diagnosis, then we use remote access, and then we get more information about it. So what this also helps us do is, when we get information through remote access, it helps us improve the diagnostics also. So in the future, whatever issues are there, we can take care of that also as part of diagnostics. So it comes in quite handy.
So it looks cool that device that can make diagnostic for itself, and
Yeah.
and you even improving it all the time. But how exactly? What can basically go wrong with it? So you said that you have some actuators that
Yeah.
could get broken, or what most often gets broken in your device?
Uh, So on the hardware front, see there are moving parts. Some actuators are there, and very small percentage of cases where the actuator can be faulty. So that is one case. Apart from that, we might have file system corruptions sometimes.
Okay.
So we have a lot of audio files, right? So we could have a case where the device is unable to open an audio file or unable to play a particular audio file.
Okay,
So
you use an Raspbian, yes? If I can ask, obviously.
yes, use the Raspberry Pi. Yeah.
Uh,
So
in
I mean,
Raspbian operating system.
that's correct. Yes. So I think it's still in that phase, and that there aren't any major concerns as such. So it's more like a safety feature, I would say. If something goes wrong, then we use for remote monitoring. But in the early stages, when we're doing the testing, because it is still in development stage, we have a lot of bugs where the code is crashing, code is not working as intended, the audio files are wrong. So in
Hmm.
those cases, we have used it frequently to communicate with the tester to change things, to upgrade the versions, and things like that. So and the on when I working with users also, we have an automatic update process that can be triggered by the user, very similar to mobile phone. So you go to settings and say download new update, right? So you can do that, and it will download the new update there. So in case in the middle they turn the switch off the device or something like that happens, there could be a chance of corruption of file system. So in that case also we can use remote access to diagnose what went wrong and try and revert it to the previous version. There are some mechanisms for that to happen automatically also, but like I said, worst case if that does not happen, this is like a fallback mechanism for us to use uh,
Okay,
in that way.
okay. But as I understand, you have no any screen. Just user needs to press some combination of buttons
Correct.
to do something.
Correct.
Okay, okay, cool.
But there's audio
So,
that guides them. So audio tells them, which menu item, settings, what to select. So audio guides them through the process.
it's audio guide that just speaks to that sound speaker.
Yeah.
Okay, okay, it sounds like interesting solution. Like it's, I'm probably not sure if I met it somewhere, but maybe.
Mm-hmm.
Well, but can you tell like how was look your remote diagnostic at beginning of your process when you just started to send the devices to people, and how did it look at now? What the differences? What have you learned? Maybe where you have learned to how to make it more efficient, how to make some improvements, how to make it faster, better.
Okay, so earlier when we were still in the testing and development phase, so we our remote access used to be always on, right? So you put it once, it remains on throughout the entire life cycle of the product. But then once we started going into more stable versions of software and more stable firmware, then we don't keep remote access always on, right?
Mhm.
So
So
we give.
user can feel safe now, like you're not spying him all the time.
Exactly, exactly. So, I mean,
Okay.
of course, we do have very solid privacy policy and terms of service that is also there, but we give the option to users to enable or disable remote access. So, by default, it is off, right?
Uh-huh.
So, we cannot access any of the devices until the user gives consent. So, there's a simple process, like I said, to give consent from the device itself, they can do that. So, once they do that, only then we have access, and that too only for that run of the device. When they turn it off, that access is cut off again. So that's a mechanism that we have built into our software.
Hmm.
You mean we do use dataplicity, but that on and off mechanism is something that we have figured out, right? So we have some
Okay.
scripts that enable that. So if you're asking me for some efficiency or building efficiency or tips and tricks into the way we use dataplicity, I would say this is probably number one that we've figured out. We figured out a way in which we can enable and disable remote access from the device itself without needing.
How, I mean, why it so improved that if efficiency? Uh, how did you do it, and yes, why it so helped?
So I think the requirement was more from the point of view of giving control to users, right? So once you have it's like a personal device that you're using to learn, right? It's your personal learning device, and you should have complete control over who has access, who does not have access, when do they have access, why do they have access. So all of it is in the user's control. So that is why it was important for us to be able to enable and disable remote access,
Hmm.
and the other thing, I mean, internally also we have a very strict mechanism and process for who can use remote access when it is enabled, right? Within us, within the company, who has access to it, and all of those regulations are there. In
Okay.
terms of efficiency, I think again, so it's basically we use a Raspberry Pi 3 Plus, right? So we have a very complex task of teaching Braille because we have a lot of hardware that we need to communicate with. We also have some server communication happening for things like downloads or new content or usage data and all of that. So in all of this, there are multiple processes running at all points in time. So having another remote access process also running, which we're not using, we don't use it all the time, we use it only when something goes wrong.
Hmm.
So for such a low frequency use process is basically draining the processor and RAM, right? So it's best for us to keep it turned off and only
Hmm.
utilize it when it is needed. That way
Yes.
all the other processes get more resources to use during regular usage. So that is
Okay.
the efficiency aspect that we have brought into the device, while not compromising on the opportunity of having remote access when needed.
Mhm. Yes, but how did you realize it? You just turning off the supervisor, the dataplicity, script by your program, or how
So,
it's
yeah, I mean,
done?
there's a supervisor that you used it. When you're installing dataplicity, you get to know exactly how it works, right? I think you have it on your website also. It is very well documented. So you use supervisor to do this, and very simple trick. So basically, the tunnel script that enables remote access to your shell, which is operated by the supervisor, you can. turn that off. You can just, so what we do is basically we rename that script to something else, and then the device, our main program then knows whether it is enabled or disabled based on the naming convention that we have used. So if it is disabled, it gives the option to the user to enable it. If it is enabled, it gives the option to disable it, and then we just restart supervisor accordingly, and then access is disabled or enabled. So it's very straightforward, but surprisingly, it is not something you have on your documentation. Maybe you should add it to your documentation, because I'm sure other users might also find this beneficial. But we use it, quite extensively, and it works very well for us.
Okay. Also, thank you for feedback. I think like if you have that, that need, probably some other users also.
Yeah,
So yes, like we always happy to listen what people say about it, and happy to make it better for people. Definitely.
absolutely.
Yes,
You guys have
Dilip.
done a fantastic job. Really happy with your product. So kudos to you guys. Thank you so much for building this.
Happy to hear it. So, um, okay, and as I understand, there is no some, constant parameters you monitor in your devices, as you like just enabling it that monitoring only in the cases when it's some errors happened. You just not monitoring anything for all the time or something like that. Yes.
Yeah.
Okay. Okay. And so Dilip, now I will ask you about another thing. You told me now about your like usual use cases, some actuators or like problems with audio files. But what was the most complicated use case you have that you really seated for a very lot of days and like already maybe need to get that device back from USA, and finally you come up with some idea and solve it.
Uh, I think there have been a very few cases where we had a software update, right? And there was some issue with the software update, and luckily we had not yet pushed it to all our users. It was still in the developmental and testing phase, and we have couple of associates in the US who tested for us, who help in testing. And this one case happened where uh, midway through the update process, they lost power to the device or something of that sort happened, and the rollback did not trigger. So if the update is incomplete, it rolls back like any other device. It rolls back to the previous stable version, but that did not trigger. And when that did not trigger, the device got bricked. It was stopped responding. It stopped
Okay.
saying anything. It stopped responding to any of the keys. But luckily, they had left the remote access on, right? So that the thing is, because it had remote access on, we were able to revive that quite easily. With otherwise, would have had to get the unit back and then reflash the entire firmware. Would have been a nightmare. So it might seem trivial here, but if you see it in the scale of things, it becomes quite a useful tool to have in terms of remote access as well. So we're thinking of enhancements in the line of adding automatic uh, turning on of remote access in case the device gets bricked, right? If there's a complete corruption of firmware where the device is not starting, maybe it can run a separate program where it takes user permission and turns on remote access. So we're thinking on those lines now, after this happened. So then that will ensure that there'll be no cases where any device will have to be recalled for software reasons, right?
Hmm.
So this was something that happened recently, so at the top of my mind. But yeah, was quite happy that day that we had data publicity and we had remote access, because it would have made my job quite tough if not for that.
Cool. And maybe it's also like good approach, as you said, to have some stable version for most of the users and have some test group of users that you will get only that new updates, and they will test it. And after you sure it's stable, you like brought it up for all the people.
Correct.
So, well, like thanks for you for another tips for our users. I think
Happy
it's
to
it.
share.
I hope it will be helpful also for many other people.
Oh, absolutely. We do have a lot of gates and lot of checks in the software. So this was one of those checks. So luckily it got caught here itself before proceeding further. So, but that also we have a distributed team that helps us with testing and being sure of our quality of software that goes out, and
Hmm.
data publicity helps there.
Okay, okay, understood. So, but you basically have devices in India and in USA, yes?
As of now, yes.
Yes, and as you said, you have that 12 languages, basically because in India it's a lot of different languages.
We do have a lot of different languages. We also have English in a couple of accents. We have the Indian accent, we have the American accent, we have the British accent as well.
Okay.
Yeah, apart from those, we do have nine Indian languages, and we are currently also developing uh, French, German, and Spanish. Uh, and yeah, I mean, we're talking to a lot more countries, and as and when we have customers from other countries, we'll build other languages as well. So if any of your viewers are interested in working with us for different languages and content support, please do reach out to me. Would be happy to have a chat.
Amazing. I will add to video description the link to your site. It's
For
like you
sure.
can easily contact with Dilip and with that company, and sure, hope I think it's a lot of people around the world that could need that such device.
Yeah. Yeah.
Mm.
I'm happy to chat about data publicity as well. If any of you are interested, if any of you want to know more about, how we're using, if you want some support or help from my side, I'm happy to help you out. If anybody wants to reach out to me, like Grigor had said, you can reach out via our website, and I'm happy to support wherever possible.
Amazing, amazing. So yes, Dilip, like, um, well, is it all like tips and tricks you have that you work with your experience and you can share, or maybe you have something a little bit more for us?
Yeah, I think these are the two major tips that I had, right? Like, I'm sure the use cases for Raspberry Pi are unlimited. There are so many different ways in which people use Raspberry Pi, but in all of them, I think it's important to have some sort of a fallback mechanism, especially when you're working with IoT or distributed devices. I'm sure all developers will try and build some security measures and some fallback, rollback, and all of it. But if everything fails, it's always good to have remote access, something like remote access. So maybe you can consider building in a trigger mechanism for it. So when your other processes fail, it can then trigger and enable remote access, and it can also notify your servers saying, "Hey, this has been enabled." So then you know that all your other gates have failed, and finally it has triggered remote access. So you can go in and see what is happening with the device. The other tip that I would say is, if you want to minimize the amount of data transfer, telemetry data, mostly to do with the health of the device, how are the peripherals functioning, how are they doing with respect to their life cycle and their health metrics. It will be a lot of data to, depending on the size of your project, it could be a lot of data to transmit every day or
Hmm.
every hour or every minute, right? So what you could do is basically have only the very crucial data pieces transmitted frequently, and all the other data you can log offline, and then you can use remote access to read those logs as and when needed. So you can minimize the amount of data being transferred from your edge devices to your servers. So that way, your network load becomes lower, and you still have access to data when you need it because you have remote access enabled. You could also make a periodic window where you have remote access enabled. So you could say every 1 hour every day for this set of devices you enable it, and then at the end of that hour it gets disabled again. It helps with all sorts of security measures also, and then that can be the time when your people can log into the device and fetch data from it or fetch logs from it. If you're working with customers, you could communicate to them also saying, this is the window in which remote access is enabled. Outside of this window, it is always disabled. So you can build scripts to work this way, not have it enabled all the time. These are just things that I've used in the past that I'm talking about. I'm sure there are more ways, interesting ways in which people use it, and I'm looking forward to more of your videos, Grigorich, and I'm sure people will have more tricks and tips coming out in that. You should probably make a web page full of tips and tricks then.
Yes, definitely.
A community page.
Trying to make some learning contact for
Yeah,
people
yeah,
to help them, to make some remote monitoring, to do some project with data with Raspberry Pi.
totally.
So yes, amazing. That was very interesting what you said, especially like when you don't need to stream all the data all the time, but just like to write most of the data to logs and just stream only the data we really need, and the rest of some debug data maybe we can only see in the log if we need it, but mostly we
Yep,
don't need all of the data and don't need to see it.
correct.
So yes, okay, Dilip. So thank you for tips for our viewers. I hope it will be helpful for many people. So my guest was Dilip Ramesh from Tinkerbell Labs, and thank you for interview.
Thank you so much. My pleasure being here. I had a great time.